And finally, our last book, Brendan Gregg's System Performance. This is the definitive, practical guide to analyzing and optimizing modern computer systems with a strong focus on Linux, which underlies so much infrastructure.
Gregg is the master of performance analysis tooling and methodology. His work is legendary.
It offers these holistic methodologies and a whole arsenal of tools for performance analysis, digging into everything from the hardware level right up to the operating system kernel and into the applications themselves.
And what's truly compelling here is its direct and immense value in the AI era. AI and ML workloads are among the most performance-intensive applications imaginable. They push every single component of a system, CPU, memory, network, storage, GPUs, to their absolute limits.
Right, they stress everything.
Achieving optimal performance and cost efficiency for AI training and inference. That's a critical business challenge for almost every company using AI today. While CSAPP gave us the theory of computer architecture, Gregg's book gives you the practical, hands-on methodology and the specific tooling for understanding how systems actually perform under load in the real world.
So it's the practice complementing the theory.
Exactly. You learn not just that a memory hierarchy exists, but how to use powerful tools like BPF, the Berkeley Packet Filter, which allows safe custom tracing in the Linux kernel to actually trace cache misses for a specific AI application running live in production. You can finally answer those tough questions. Why is my expensive GPU sitting idle half the time? Why is network latency so high between my distributed training nodes? Gregg gives you the methods to find out.
Now, a common misconception is that performance analysis is some kind of black art, requiring arcane knowledge. Or, maybe more recently, that new AI-powered observability tools will just solve everything automatically. I imagine it's more nuanced than that.
It absolutely is. While modern observability tools, some using AI, are fantastic for flagging anomalies, hey, CPU utilization spiked. They often don't replace the need for deep human understanding to find the root cause.
They tell you the what, not the why.
Precisely. An AI tool might say CPU utilization is high, but it usually can't tell you why. Is it inefficient application code? Is it contention within the operating system kernel? Is the system spending all its time context switching between processes? Gregg's book teaches the methodical approach, like his USE method, to systematically drill down from a high-level symptom to the underlying root cause.
What's the USE method?
It stands for utilization, saturation, and errors. For every key system resource, CPU, memory, disk, network, you check its utilization. How busy is it? Its saturation, is there a queue forming? And if it's generating any errors. It's a systematic way to quickly identify potential bottlenecks. Relying solely on automated tools without this kind of methodical understanding is like seeing a warning light flash on your car dashboard, but having absolutely no idea how an engine actually works. You don't know where to even start looking.
So how would you apply this USE method to diagnosing a slow AI training job? Maybe one where the expensive GPUs seem underutilized.
Okay, great example. You'd apply the USE method systematically. Check GPU utilization, maybe it's low, like 50%. Okay, why? Then you check utilization, saturation, and errors for the other resources. CPU. Maybe the data loading and preprocessing cores are pegged at 100% utilization. Memory. Maybe memory bandwidth is saturated. Disk I/O. Maybe the storage system is saturated, with long queues, high saturation, trying to read the training data.
So the GPUs are starved for data.
Exactly. You've identified an I/O bottleneck as likely the root cause, not the GPUs themselves. Once you understand that, you can then use an AI assistant much more effectively. You can ask a targeted question like, okay, given an I/O-bound workload on a parallel file system, what are the most efficient file formats and data loading strategies to use in PyTorch to maximize throughput? Now the AI can give you relevant advice.
That makes perfect sense. Diagnosis first, then targeted remedy.
Precisely. Expertise in systems performance analysis is unfortunately rare, but incredibly valuable. In the world of AI, where single training runs can cost millions of dollars, an engineer who can methodically diagnose bottlenecks and shave, say, 20% off that training time, they provide a massive direct return on investment.
Huge ROI.
This skill is fundamentally about diagnosis, investigation, optimization, creative problem-solving activities that are inherently difficult to fully automate. While AI can certainly assist with data collection and maybe suggesting hypotheses, the deep holistic analysis connecting hardware, kernel, and application behavior within a complex production system, that remains a deeply human endeavor.
This positions you as the ultimate performance expert, a high-impact, high-visibility, and incredibly high-value role that will be in demand as long as we continue to push the boundaries of computation.
As long as performance matters, the skill will matter.